Okay, so today what we're going to be doing is drawing the rock cycle. The rock cycle, it seems like it's a perfect circle, but it's not. We're going to start off with magma. Magma, of course, is a molten material deep down within the mantle of the earth. When it rises to the surface, it then becomes lava. It doesn't magically change. It's just that it's the geologist's way of knowing if it's underground, if it's intrusive, or if it's on the surface and extrusive. That magma, in order to become an igneous rock, has to go through a process. So wherever you're seeing those red arrows, that's a process. The process to turn into that igneous rock is it needs to cool and crystallize. Right? So it's going to cool and crystallize to become the igneous rock. Igneous, by the way, means fire. So that's why they came up with igneous rock. Those igneous rocks can break down and become sedimentary rocks. They're going to break down by weathering and erosion. That weathering and erosion, we usually say those terms together. However, the terms aren't exactly together. They mean very specific, different things. For example, if this piece of paper is a rock, breaking it apart, that's a physical weathering, type of physical weathering. I could burn this piece and that would be chemical weathering. The erosion comes in the fact of the transport of the material. Those sediments are then going to have to do something. Those sediments are going to have to deposit, so we're going to call that deposition. After that, they're going to go through a process called compaction. And lastly, cementation. On your way into the school, no matter if you're dropped off by parent drop off or you come in from the buses, you must walk on sidewalks. And those sidewalks are made with cement. This is the easiest way to think of sedimentary rock because that sedimentary rock, that cement mixer, has to bring in that rock and they're going to first deposit it. They're going to pour it into that area and then it has to be compacted down. Once it's compacted down and that water begins to evaporate out, it then cements. And you can actually see these terms in here. Deposit, meaning to be laid down. Compaction, of course, is to compact the materials. And then, of course, cement. As we move on, that sedimentary rock can become a metamorphic rock through heat and pressure. The metamorphic rock can return to the magma with melting. So we have this perfect circle, but we don't. There's this big open hole in here because there's a lot of short circuits. There's a lot of things that can be skipped. See, igneous rock doesn't have to break down to become a metamorphic rock. It can sidestep everything and just become metamorphic rock. The key to this is always look at the arrowhead, right? Because the arrowhead, the processes are going to be the same. Everything leading to metamorphic rock is going to be heat and pressure. In fact, to finish off heat and pressure, some of these metamorphic rocks can turn around and become a different metamorphic rock with heat and pressure. Now these sedimentary rocks, right now we have the sedimentary rocks becoming metamorphic. The sedimentary rocks are not going to go back and become igneous, but they can go directly to magma. Of course, if we follow the arrowheads, it's going to go directly to magma by melting. And you know, the igneous rocks, they can just go straight back to magma through melting. These metamorphic rocks can break down. In fact, Michelangelo used to love to break down things like quartz, marble. Marble is marble. That's what he used for a lot of his sculptures. So, of course, seeing the arrowhead, we know that it's going to be weathering and erosion.